Okay, you can start. Are you able to see the screen?
Yes, sir.
Yes, okay, fine. Then, okay, partial differentiation basics. So, what is that derivative? Already we have seen that what is meant by derivative. If y equal to f of x is a function of one variable, then the ordinary derivative is dy by dx. That is what differentiation of y with respect to x. So in the numerator always the numerator always dependent variable is there. Dependent variable is there. The denominator always independent variables. Okay, that is if we extend the concept for that more than one variable, we extend the concept for more than one variable, then we can do partial differentiation. So in the partial differentiation, just we can take that view, this ruler we can take. Okay, fine. What is meant by that partial derivative is that in case consider the function let's consider the function some z equal to function of x comma y. Z is a function of x comma y. Then z is a dependent variable in x and y. X comma y are the independent variables. if we want to differentiate this z equal to f of x comma y, then either you have to differentiate with respect to x, or either you have to differentiate with respect to y. Okay, at the time we can write that the symbol dou. Dou is the symbol of partial derivative dou by dou z by dou x mean you are differentiating z with respect to x, keeping y as constant. Y as constant. Whereas one person is waiting there. Okay, one is waiting here. Fine. So whereas if we are differentiate z with respect to y means keeping x as constant. Okay. So what are the notations are there? Important notations are there. Important notations. What are the notations are there? First we can keep it that what is the function? Let z equal to f of x comma y is the function. Then what are the first order partial derivatives? First order partial derivative. So what are the first order partial derivatives are? Dou z by dou x, comma, dou z by dou y. That means dou z by dou x is differentiation of z with respect to x. This one is differentiation of z with respect to, just wait, I want to close this WhatsApp. Okay, fine. Now it's clear. Differentiation of z with respect to x. Second one is differentiation of z with respect to y. So when you are differentiation of z with respect to x mean keeping y as constant. When you are differentiation of z with respect to y means keeping x as constant. That is the first order partial derivatives. Second order partial derivatives are order partial derivatives. So what are the second order partial derivatives are? dou square z by dou x square. That means you are differentiating of dou by dou x, dou z by dou x with respect to x again. Okay. Second one is dou square z by dou y square. That means you are differentiating with respect to y of dou z by dou y. The last one is dou square z by dou x dou y. That means you are differentiating dou y by dou x, sorry, dou y by dou y. You are differentiating dou y by dou y with respect to x, or differentiating dou y by dou x with respect to y.
So there should be Z there.
Yes.
Dou Z by dou Y.
Yes. I am writing as the ordinary differentiation. Exactly. Okay. Dou z by dou y and dou z by dou x. Whereas both are same, either you have differentiate dou z by dou y with respect to x or dou z by dou x with respect to y. So these notations are can be written as here this dou z by dou x is there now. The dou z by dou x can be written as small p. Dou z by dou y can be written as small q. This dou square z by dou x square is there now. This is denoted by small r. This dou square z by dou y square is small t, and then this dou square z by dou x dou y can be written as small s. So p, q, r, s, t are that the notations of first order and second order partial derivatives. Where you go for the third order partial derivatives, third order partial derivatives are dou cube z by dou x cube, dou cube z by dou y cube. One more is dou cube z by dou x square dou y, comma dou cube z by dou x dou y square. So generally these are the partial derivatives notations. Sometimes you are differentiating z with respect to x, means that simple notation. Another notation is that first order partial derivatives are, sometimes it may be written as the dou z by dou x is there now. Sometimes they may be written as z suffix x is that dou z by dou x. Sometimes they are writing that z suffix y is dou square z by dou y. And then one more notation for that second order is the dou square z by dou x square also can be written as z suffix xx. Then this dou square z by dou y square can be written as z suffix yy, and then dou square z by dou x dou y can be written as, it can be written as z suffix xy. That means, or you are differentiating z with respect to x, then with respect to y, or z yx, both are same. Okay, whereas third order, in case if you are writing the third order, then we can write this as z suffix x x x. This can be written as z suffix y y y. This can be written as z suffix x x y. Don't write x square y, x x y. Otherwise, this can be written as z y y. Okay, so and so on. You can write up to nth order. Okay. Now we can see how to find that the partial derivative problems. See, for example, first problem we can take. Let f of x comma y equal to x cube y plus y square x plus 7. So what are the things you need to be calculate is dou f by dou x, dou f by dou x at minus 1 comma 3, dou f by dou y at minus 2 comma 1. So how can we find this? Write the solution for this. F of x comma y given f of x comma y equal to x cube y plus y square x plus 7. So what is dou f by dou x? Dou f by dou x is you are partially differentiate with respect to x, keeping y as a constant. Just wait and see that anybody is waiting. One more person joined. So here that meaning is differentiation of f partially with respect to x, keeping y as constant. Keeping y as constant. So here, in case if you have differentiation of f keeping y as constant, so where is the constant terms are there? What are the constant terms are there? When you are differentiating with respect to x, keeping y as a constant means, so what are the constant term for this? This term is constant and this term is constant. This term is constant. What are the variable terms are there? This is the variable. This is the variable. Is it not? So now you have to differentiate with respect to x means y is a constant, na? Keep it y, and the differentiation of x cube is 3x square. Are you following this? Plus.
Yes, sir.
Okay. So second one is if you are differentiating with respect to x, keeping y as a constant mean. So y square is constant. Differentiation of x is 1 plus differentiation of 7 is 0. Therefore 3y x square plus y square plus 0. So 0 you can leave it. No need to write the 0. Now we have to find the dou f by dou x minus 1 comma 3. That means dou f by dou x at first value is x, y value is 3. So in case if we are substituting this value here means then dou f by dou x at minus 1 comma 3, that is equal to 3, y equal to 3, x square is minus 1 whole power square plus y square 3 square. So 3 plus 3 9 plus 9 18. That is first one. Second one is dou f by dou y we have to find. So next we have to find dou f by dou y. Dou f by dou y means differentiation of f partially with respect to y, keeping x as constant. So what is the variable here? Y is variable. Therefore, based on that f, you can write that y as a variable and x is a constant. X is a constant. So therefore, we can write here dou f by dou y we have to write now. So what is f here? F equal to, what is f? F is x cube y plus y square x plus 7. So based on this, what are the variables? Y is the variable. Here also y is the variable. Constant is x is a constant. So wherever x and other values are, these are the constant. So now you have to differentiate with respect to y. That means keeping x cube is constant, differentiation of y is 1 plus keep it x is a constant, differentiation of y square is 2y plus differentiation of 7 is 0. That means you will get x cube plus 2x. But they are asking the dou f by dou y at the point of minus 2 comma 1. So that means what? Dou f by dou y at x equal to minus 2, y equal to 1. That is the meaning. So you can write here x cube, x is minus 2 whole cube plus 2 into minus 2 comma 1. So minus 2 whole cube is 8, minus 8 and then minus 4 minus 2 is the answer for this. Now we can do one problem. Second problem.
Yes, sir.
Any doubt is there?
No, sir.
Okay. Let f of x comma y equal to sin xy square plus e power x cube plus x cube plus 5y. Calculate dou f by dou x. dou f by dou x, dou f by dou y, dou f by dou y, dou square f by dou y dou x, and dou square f by dou x dou y. Here f is given that what is f is given, f of x comma y is given function sin of xy square plus e power x cube plus 5y. Now we have to find dou f by dou x. So dou f by dou x means you have to write y is constant. If you understand means no need to write this. So y is constant means what are the constant term here? Y this time is constant, then this time is constant, the whole time is constant. So therefore we can write here sin of xy square. Sin of xy square means differentiation of sin x is cos x, but we have to do in chain rule. That means differentiation of sin xy square, keep it xy square is t, then differentiation of xy square with respect to x is dt by dx equal to y is constant, so keep it y square, differentiation of x is 1, so y square here. That means dou f by dou x is sin of xy square is there, differentiation of sin is cos, whatever the function is there you have to write. Okay, then differentiation of xy square is y square plus e power x cube plus 5y is there, then e power x is differentiation of e power x is e power x only, so therefore e power here down I am writing plus e power x cube plus 5y, that is equal to y square, keep it here, and then in the x cube plus 5y is there na, you have to differentiate that x cube plus 5y with respect to x. So x cube differentiation is 3x square, 5y differentiation is 0, therefore y square cos of xy square plus 3x square e power x cube e power x cube plus 5y. So it is dou f by dou x by keeping y as a constant. Next we have to find dou f by dou y. Dou f by dou y means keep x as constant. That is equal to, so in case if you are keeping x as constant, what happen? Sin x is cos x only, cos of xy square, that is not changing, but the differentiation of xy square with respect to y is keeping x as a constant, differentiation of y square is 2y plus e power 3x cube plus 5y. E power x cube plus 5y is the same thing, but differentiation of 5y is fine. So that means dou f by dou x is 2xy cos xy square plus 5 e power x cube plus 5y. So that means dou f by dou x equal to 2xy cos xy square plus 5 e power x cube plus 5. Next we have to find second order derivative, either dou f by dou x with respect to y or dou f by dou y with respect to x. So that means we can find that dou square f by dou x dou y. That means dou by dou x of dou f by dou y. So dou by dou x of dou f by dou y. Dou f by dou y is here. So what is dou f by dou y? Sorry, it is dou f by dou y, no? Not dou f by dou x. So that means dou by dou x of dou f by dou y is 2xy cos xy square plus 5 e power x cube plus 5y. But you are differentiating with respect to x means keep it y as constant. Therefore, you will get that if you are differentiating keeping y as a constant with respect to x means so here what are the values are constant, y is constant. Where is the constant terms are there? This is the constant term, 2 is the constant one. So this y here is constant, this y is constant, y is constant. The other values are variables. Now we can differentiate this with respect to x. Keep it that constant value. First you keep it that, then remaining x and cos xy square is there. What is differentiation of x cos xy square? That is, it is d of uv model, u dv plus v dv. What is u here? X is u. Differentiation of cos is minus sin xy square, and then differentiation of xy square is that y square. Differentiation of x is 1 now, and then plus keep it cos xy square, differentiation of, but outside 2 also is there, so differentiation of x is 1. So you are keeping the 2y is constant. Now you can write this value here. You will get that, what you get, x y square minus is there, minus xy square sine of xy square plus cos of xy square. It is only one term is over. So I am writing that separately how you are getting this. So I can, because one more word, sorry, one more term I need to write now here, plus 5 into x cube plus 5y square. So this, if you are differentiating that, you will get that it's totally different term. So one more time is here. The term is plus 5 e power x cube plus 5y. Differentiation of x cube plus 5y is 3x square. So that is equal to 2y into minus xy square sine of xy square plus cos of xy square, and then plus 5 into 3 15, 15x square e power x cube plus 5y. So this is the answer for tau square x by, sorry, tau square f by tau x tau. So similarly you can calculate that tau square f by dou y dou x. Function of function rule. What is mean by that? Function of function rule. It is so much important. Even in the last class also we have discussed about the function of function rule. Function of function. In case if I consider one function w of x and x and y are the function of t, the same thing you are reading in function of several variables. So w is the function of x and y, and then x and y are the function of t. Then you can write that w is the function of x comma y, x is the function of t, and y is also the some function. But I want to find that dw by dt. I want to differentiate t, but w is not the function of t. W is the function of only x and y. X and y is the function of t. So you have to differentiate. In case if you want to find that dw by dt means, why you are writing dw by dt, why you are not writing the dou w by dou t, is that it is that ordinary differentiation, because x and y is the function of only one variable t. Then we have to write the dw by dt here. That means dou w by dou x. So first you have to differentiate w with respect to x. That means you come here, and then through x you are going to t. Otherwise w is a function of y also. You have to come to w to y, then y to t. It is known as that function of function rule. Then in case if you want to find that dw by dt, you will get the dou w by dou x and dx by dt plus dou w by dou y into dy by dt. Now can you get it? Once again I explain. W is the function of x comma y, whereas where x is the function of t, sorry, y is the function of t, x is the function of t, y is the function of t. W is the function of x and y means x is here, y is here. We can find dou w by dou x and then dou w by dou y. But x is the function of t na, then we can find dx by dt. Y is the function of t na, then we can find dy by dt. Then if you are writing combinedly, dou w by dou x into dx by dt or dou w by dou y dy by dt. What is the value of this? dw by dt. Hmm. So this is known as the function of function rule. By using one simple problem, we'll see how to find this. F of x comma y equal to, for example, f of x comma y equal to x square minus 2y square is there. Where x of t equal to cos t, y of t equal to e power t. See, this problem will come. This one important problem. F of x comma y equal to x square minus 2y square, where x of t equal to cos t, y of t equal to e power t. Then I want to find that df by dt, capital F, that is equal to dou f. First you have to differentiate x, then you have to differentiate with respect to t. Dou f by dou y dy by dt. You can see here what is the notations you are using. What is the concept behind this? See, d and dou, two different notations are there. D means ordinary differentiation, this dou is there, na? It is a partial differentiation. Just wait. Hello. Yes. Yes, quick. Tell me. Okay. See, anybody here, we can see that whenever we write that d means the function is function of one variable. D means
Sir, your screen is not visible.
screen is not visible. Just wait.
It
No,
is
no,
visible, sir. It is visible.
it is visible only, I think.
Yes, sir.
Yes, yes.
No, just here I want to explain that if this point is clear, then easily the other point you can understand. Here, df by dt, why you are writing that d here, why you should not write the dou? What is the difference between d and dou? D means ordinary differentiate, dou means partial differentiate. When that function is that function of two variables, then only we can do that the partial derivative, otherwise it is not possible. Listen, for ordinary differentiation, function is only one variable. That means there is no other variable here. Function is, it may be that function of x comma y, but x and y are the function of only one variable t. That means f is the function of x and y, but x and y are the function of t. So I want to find that df by dt through this x or through this y. That means either I can come df by dt through that x I am coming, and then I can reach t, or through that y I can reach t. So in middle I can write r. So df by dt equal to, here I am writing one more time, df by dt equal to, first I can differentiate with respect to x, dou f by dou x, and then I differentiate x with respect to t. That means dx by dt. So whenever you are writing that this x with respect to t, means you have to write that d, since x is the function of only one variable. Okay, plus dou f by dou y, plus means r, this plus is there now, this plus means r. I can reach from f to t through the path x or through the path y, that is the meaning. So dx by dou f by dou y into dy by dt. Okay, so you have to find that value dou f by dou x and dou f by dou y and dx by dt, dy by dt, then substitute in the formula. So what is f here? F is that x square minus 2y square dou f by dou f by dou x means you have to keep it y as a constant. Differentiation of constant is 0. So only x is the variable here. Differentiation of x square is 2x. 2x minus 0, 2x. Since y is a constant. Similarly, dou f by dou y equal to differentiation of f with respect to y na. So keep it x as a constant. Differentiation of constant is 0 and then differentiation of 2y square is 4y. Now we have to find that. So dou f by dou x is over, dou f by dou y is over. Next we have to find dx by dt, dy by dt.
Sir,
Dx
your
by dt.
screen.
What?
Your screen, sir.
No, it is visible only. Thing. I'm sharing. See that I am not stop sharing. I'm sharing my screen only. I don't know why you are not able to see that. Everyone not able to see my screen.
No, sir, it's visible.
So dx by dt is, what is x here? Cos t. Cos t differentiation is minus sin t. Similarly, dy by dt equal to e power t differentiation is e power t only. Therefore, you have to substitute all the value in the formula. Df by dt equal to dx by dt. Dx by dt is df by dt is 2x and dx by dt is minus sin t. Thus dou f by dou y. Dou f by dou y is minus 4y and then dy by dt. Dy by dt is e power t. So therefore minus 2x sin t minus 4y e power t. But df by dt means it should be the function of t. It should not be the function of x and y. Okay. Therefore, substituting x and y here, we'll get that df by dt equal to minus 2. X is cos t and then sin t, we can write minus 4 y. Y is e power t into e power t. So that is minus 2 sin t into cos t minus 4 e power 2t. Actually, one formula is there, one trigonometric formula is there. Sin 2a equal to 2 sin a cos a is 2 sin a cos a is that. It is one important formula. Using this formula, we can write this as minus sin 2t minus 4 e power 2t. It is df by dt. This is the answer for this. Okay. See, once again I repeat that. Listen. Once again I repeat some rough work I am doing here. In case f is the function of x and y, but x is and y is the function of t, then from this f we can find that dou x by not dou x, dou f by dou x, dou f by dou y. There are two possibilities is there from f, because f is the function of x and y, function of two variables. When it is a function of two variables, then the partial derivative is possible. Partial differentiation is possible. Only one variable is there, partial differentiation is not possible, then you have to do only the ordinary differentiation. But x and y is that function of only one variable, then we have to do, there is no other way, only one derivative is there, that is we can differentiate dx by dt, dy by dt. But carefully you have to write this notation dou and t. Okay, so I need to find that df by dt, df by dt. So I want to come from, I want to come from f to t. It is like that path. Okay, f to t I want to come. Either I can journey from f to x and then x to t, I can reach t. Otherwise I can take the path from f to y, again I can reach the t. So this r means in mathematically, sorry, r means plus and means multiplication. Okay, so therefore if you are writing this combination of this, then we will get the answer. That means dou f by dou x, dou f by dou x dx by dt plus dou f by dou y into dy by dt. Now we come to that next one. In case in the same same method, I extend the concept. In case f is the, if f is the function of x and y, comma, x is the function of u and v, y is the function of u and v, then how can I differentiate? F is the function of x, f is the function of y, x is the function of u and v, y is the function of u and v. Then what are the possible derivatives are there? Here f is also the function of two variables. F is the function of two variables. So what is the difference between the previous case and this case? X comma y also the function of two variables. So what is the difference between that last case and this case? Because this is very important. You are studying that same thing in that chapter, na? In that unit 2. Oh, 157 is asking, it's not showing for him. Arey, am I audible first?
Yes, sir.
Screen is visible. Screen is visible or not?
Yes, sir.
Okay. Screen is visible means can you tell me that what is the difference between the last case and this case?
So in last case, x and y have only one variable,
One variable. Here x
and
and
but
y has two
have
variables.
two variables. Yes, sir.
Okay. So here there are two possibilities are there. Here also we can find the dou f by dou x, dou f by dou y. And then here we can do that dou x by dou u, dou x by dou v is possible. Dou x, dou y by dou u, dou y by dou v is possible. Is it not? So at the time, if you are multiplying this, then what are the things you maybe get? That means I want to find that differentiation of partial differentiation of x f with respect to u. Partial differentiation of x with respect to u. That means I want to come from f to u by through this way also I am coming to u, by through this way also I am coming to you. Okay, so what are the possible partial derivatives are in the way? Either dou f by dou x, dou f by dou x into dou x by dou u plus dou f by dou y into dou y by dou u. See, previously it is that the function of f of x comma y is the function, and then x and y are the function of t. Here f is a function of x and y, x and y also function of u and v. Therefore here you can see I am writing dou here, but in the previous case I am writing that d here. So the reason is, you should know the reason why I write the d under dou in the left hand side. Similarly, if I want to find the dou f by dou v, I want to find the dou f by dou v. So it's this type of problems are known as that function of function rule. Okay, so dou f by dou v means first I need to find that dou f by dou x and dou x by dou v plus dou f by dou y into dou y by dou v. Okay, see here, are you able to get that the difference between this last case and this case?
Yes, sir.
So in this case any doubt is there, let me know, because if you are understand means then it will be so easy for your problems. So once again I repeat that this concept, once again I repeat that concept. Through the diagram I can explain this. F is the function of x and y, so that means f is the function of x, f is the function of y. At the time we can write that dou f by dou x, dou f by dou y. Okay, so and then x is the function of u comma v, y is also the function of u comma v. Okay, at the time we can get that dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. So I want to find that dou f by dou u. Dou f by dou x means directly we can get. But what about the next step? In case if you want to come to that next step, then either you have to this one and come to u here, and then this one come to u here. This is one way. The second way is if I want to come to v means either you come to x, x to v, and then come to y, and then come to v. So your combination of these two is dou f by dou u is dou f by dou x, dou f by dou x, only green I am writing, into dou x by dou u, plus only green I am writing, dou f by dou y into dou y by dou u. Similarly, I want to find that dou f by dou v. If I want to find the dou f by dou v means only yellow I am writing. I'm not able to see yellow maybe. Dou f by, yes, it is not visible. Instead of yellow I am writing some dou f by dou y to dou y by dou x plus dou f, no, not dou y by dou x, v you should get dou f by x you have to write. Okay, I need to change this. Dou f by dou x, dou x by dou v, dou f by dou y, dou y by dou v. So this is the concept behind this two partial derivatives. This type of derivative is known as the total derivative. Total derivative. See here how to calculate the total derivative. I want to take some problems from your book because it will be useful to you. Your books means mathematics 1 you are finding na. That same thing we are doing now. One or two problems from your chapter functions of several variables. It is sequences. Yeah. Write this. battery is low. Okay. It is disconnected. 1 minute wait. Yeah. Now you can continue here. Solve an example from that maths 2. First I want to write that note before we go to that example. I want to write that note. The note is dz by, that means df by dt is the df by dt equal to dou f by dou x, already written dou f by dou x under dx by dt plus dou f by dou y into dy by dt. This is called that total differential coefficient. Total differential coefficient of f. And one more important definition is that if I want to only df, not dt, df is dou f by dou x dx plus dou f by dou y into dy. That means df equal to dou f by dou x into dx plus dou f by dou y into dy is called total differential of f. Total differential of f. Now only we are entering into your syllabus functions of several variables. Okay, so in the functions of several variables, what are the important things you have to be consider is uh, first one is what is meant by total derivative. What is meant by total derivative? Second one is function of function group. If you clear in that two concept means, then we will be solve all the problem in this chapter. See, for example, writing that in case if u equal to xy plus yz plus zx, where x equal to e power t, y equal to e power minus t, z equal to 1 by t. Then find du by dt. Then u is given, it is clear, u is the function of xyz, where x is the function of t, y is the function of t, z is the function of t. Okay, so I want to find the du by dt, but du by dt, as the diagram, already draw one diagram now. U is the function of x, function of y, function of z, and x and y and z all are function of t. So dou u by dou t means we can find that dou u by dou x, dou u by dou y, dou u by dou z. Here you can find that dx by dt, dy by dt, dz by dt. So what is du by dt here? Dou u by dou x plus, dou u by dou x into dx by dt into dx by dt plus dou u by dou y into dy by dt plus dou u by dou z into dz by dt. What is u here? U is xy plus yz plus zx. Okay, dou u by dou x means keep it y and z are constant. So y and z are constant mean keep it y here. Differentiation of x is 1 plus both y and z are constant here. Y is z, it will be 0. Z and x is there. Z is constant, keep it z. The differentiation of x is 1. So y plus z dou u by dou x. Similarly dou u by dou y. See, if your differentiation of u with respect to x means without x you are getting that y plus z. So dou u by dou y means you will get that x plus z. Similarly dou u by dou z means you can do that step by step also. Just I am doing that directly. But here dou u by dou z means without z we can write that x plus y. Now the remaining value dx by dt, dy by dt, dz by dt we need to find. What is x here? X is e power t, then dx by dt equal to e power t, y equal to e power minus t. That implies dy by dt equal to minus of e power minus t, z equal to 1 by t, dz by dt equal to minus 1 by c square. Okay, therefore substituting all these values in du by dt, du by dt, du by dt is dou u by dou x, dou u by dou x is y plus z, and then dx by dt is e power t plus dou u by dou y, dou u by dou y value is x plus z, and then differentiation of dx by dt, dy by dt is minus of e power minus t plus d dou e by dou z. Dou e by dou z is value x plus y. Dou e by dou z is x plus y, and then minus 1 by t square. Yeah. So here, in case before you multiply all the things, you have to resubstitute all the value. That means what is y here, what is z here. Y is e power minus t plus z is 1 by t, e power t is plus once again x is e power t plus z is 1 by t minus of e power minus t, then plus x plus y, e power t plus e power minus t minus 1 by t square. Okay, either you can leave as it is, otherwise you have to multiple and expand this. So e power minus t, e power t is that 1 plus e power t into 1 by t plus e power t, e power minus t is minus is there, minus 1, multiply this, minus e power minus t into 1 by t plus e power t, e power minus t is that not plus minus, minus we can write outside, minus here 1 by t square e power t plus e power minus t. Is it clear the problem or any doubt is there? See, for this class you have to be very clear cut idea about that total differential and the function of function rule and chain rule. Okay, in particular you have to be get idea in this as I told na, if function of only one variable and function of two variables, how can you calculate? It is a function of one variable, first we have done that df by dt. In case if it is a function of two variables, then how can we do this? So case if it is very clear in that these two concepts means, then you can solve any problem in function of several variables. Okay, fine. Then in the next class we will go for that one important topic, and before we go to the topic, then we can see few more problems in this function of several variables. Then we go move to the Jacobian in the next class. Okay, is it clear?
Yes, sir.
So any other
Yes,
doubt is
sir.
there, let me know. Now up to now, what are the things you feel that difficult? What are the things you need to be clear? I want to know.